All right, let's talk some implicit differentiation. So this is coming from section 4.4 on implicit. Okay, and the key thing with implicit is that when you multiply, when you differentiate, meaning take the derivative, a y, you multiply by dy over dx. And the reason for that has to do with chain rule, right? Because essentially our y has hidden x's inside of it. Okay, so how does this play out? So let's take a look at a couple examples. We'll do let's do two. So number one, let's say that we've got x squared y cubed plus x equals y squared. Okay. So in this case, what I'm going to do is I'm going to differentiate left to right. I'm going to use my rules where appropriate. So if I'm multiplying two things, I'm going to use product rule. If I'm dividing two things, I'm going to use quotient rule. If I have something to a power, I'm going to use chain rule. Okay. But whenever I take the derivative of a term with a y, I'm going to multiply it by dy dx. So we're going to work our way from left to right. So the first term on the left is the x squared y cubed, this one. And this one has two things multiplied together. I've got function 1 and I've got function 2. So I'm going to set it up using product rule. So function 1 is the x squared and its derivative is 2x. Function 2 is y cubed. Now, when I take the derivative of y cubed, I use my rules as normal. So my derivative would be 3y squared, but this is a y. So I'm differentiating a y, so I'm going to multiply it by dy over dx, okay, which means the derivative of y. Okay, now my setup is good. So now I want to put it together using my product rule. So I want my 1 prime 2, so that's 2xy cubed, plus 2 prime 1, so that's 3y squared, and I'll put my x squared in front of the dy dx because I like my dy dx at the back. And the order doesn't matter when you're multiplying. If you don't like that, your x squared can go behind your dy dx. No problem there. Okay, that takes care of our first term. That one's done. So now we move to the next one. So plus x. The derivative of plus x is plus 1. Equals the derivative of y squared on the right-hand side is going to be 2y, but this is a y, so we're going to multiply it by dy over dx. Okay, now I've done taking derivatives, but what I want to do is I want to be able to solve for my dy dx so that I can say the derivative is equal to this, okay? And so I'm going to notice that I have two terms that have dy dx in them, and I have two terms that don't, okay? And so I want dy dx by itself. So I want to put dy dx is on one side and everything else on the other. I can do that most efficiently with this one if I subtract the 3y squared x squared dy dx from both sides, because that will put both of my terms with dy dx on the right and my terms without on the left. So on the left, I'll have the blue ones. So the 2xy cubed equals plus 1. And on the right, we have the 2y dy dx minus the 3y squared x squared dy dx. Okay. Now, my objective is to get dy dx by itself. So what I'm going to do next is I'm going to factor it out of the right-hand side because they both have one. So if you, by the way, if you don't like that your variable's on the right, you can flip-flop your sides at this point. So let's factor out our dy dx. So this side stays. And I'm going to take out the dy dx to the front. And when I take out the dy dx, I have 2y minus 3y squared x squared. And to get our dy dx by itself, we're just going to divide both sides. So that's going to give me, and I'm going to flip the sides here. So I'm going to put dy over dx on this side. Okay, the top is the 2xy cubed plus 1, and I'm going to divide both sides by 2y minus 3y squared x squared. And that's my final answer. So our goal is to take our derivative from left to right, and then once we have it, we're going to solve for dy dx. Okay, so let's look at one more, maybe one that has quotient rule. Okay, so let's look at one that says, let's see. Let's go xy plus x squared over y equals 5. So in this case, I have an x and a y that are being multiplied. So that's going to mean product rule. And I've got an x squared divided by y, which is going to mean a quotient rule. So I'm going to have two separate setups here. So for the one on the left, x times y, this is my function 1. This is my function 2. So function 1 is just x, and its derivative is 1. For function 2, we have y, and its derivative would be 1, except it's a y, so we want dy over dx. And that way, when we put together using our product rule, we have 1 prime 2, which is just y, plus 2 prime 1, which is x, dy over dx. Okay. Next, that takes care of this first term in blue. So now we want the second term in yellow. And that one's division. So I'm going to have to set that one up using quotient rule. So let's start with the top being x squared. And its derivative is 2x. And the bottom is a y. And its derivative, again, is dy over dx. So our next is plus because of this plus right here. And then we want to use our quotient rule. So top prime bottom would be 2xy minus bottom prime top, x squared dy over dx, all over the bottom squared, which would be y squared. So that's our quotient rule. Then we've got an equal sign, and the derivative of 5 is going to be 0. Okay, so that takes care of our derivatives, and now we just need to solve for our dy over dx. And you can see that I've got 1 here, and I've got 1 here. The problem with the second one is that it's kind of inside that fraction. So the first thing I want to do is I want to clear out my fractions so I don't have to worry about them. So I'm going to take everything and multiply it by y squared so I can clear that denominator. Okay, so that means I'm going to have to distribute it here, here, and here. So when I do that, y squared times y will give me y cubed. Y squared times x dy dx is going to give me x y squared dy over dx. Again, the order that you multiply doesn't matter, so I like to put them in alphabetical order. It doesn't matter to me if you write it differently. The third piece, y squared on the top and the y squared on the bottom are going to cancel out. That was our goal. So that means we just have the numerator. So 2xy minus x squared dy dx equals 0. We also multiply the y squared here, but 0 times y squared is just 0. So now I'm in a position where I've got 2 dy dx terms, but now I don't have any fractions to worry about. So I want to get those by themselves. So what I'm going to do this time is I'm going to subtract the stuff that doesn't have them to the other side. So I'm going to subtract the y cubed and the 2xy. So y minus y cubed minus 2xy. That will leave me with the xy squared dy over dx minus the x squared dy over dx is the negative y cubed minus 2xy. Okay. Now from here, I want to factor out that dy dx. Let's move it to the front. So when we take it out, we have xy squared minus x squared is left over, and nothing on the right changes. And then last but not least, we're going to divide both sides by what's in the parentheses so that I can get my dy dx by itself. And that's going to leave us with dy over dx is equal to negative y cubed minus 2xy all over xy squared minus x squared. And that's our final answer.